Good morning, students. You are welcome for the next episode, number 4. In the last class, we discussed about equations of motion such as V is equal to U plus AT, another S equal to UT plus half AT square, and third one 2AS equal to V square minus U square. Now we want to get this relation from graph. Among that, first velocity time relation from a graph. Suppose a body moving with a uniform acceleration. Suppose a body moving with a uniform acceleration and its velocity time graph is represented as AB. A body moving with a uniform acceleration. Its velocity time graph is represented here. AB is the velocity time graph. Here U not equal to 0. Here U not equal to 0. See, we draw a line perpendicular to time axis. Let it be BC. Here BC represent final velocity V. BC represent final velocity V. OA initial velocity U. OA initial velocity U. And OC time. Now drawn a line parallel to OC, that is equal to this point is D. Now AD equal to OC. AD equal to OC. See here. Now we know BC equal to we can write CD plus CD plus BD. From this BC is the final velocity is equal to, and CD is equal to OA. CD equal to OA, that is initial velocity U plus BD. From this, to get BD, this U be shifted to this side. Now what we get, BD is equal to V minus U. This we can take as relation 1. Once again, BC equal to CD plus BD. This is CD plus BD. And this BC we know final velocity. And this C to D, this part is equal to OA, initial velocity U. This is initial velocity. And so V is equal to U plus BD. From this BD is equal to V minus U. That we can take as relation 1. Now, again we know acceleration A is equal to change in velocity by time. Here, this is the initial velocity and this is the final velocity. How much is the change in velocity? That is equal to BD by time. That means AD. But that AD. Now see, A is equal to BD divided by AD. This AD and OC equal. But we know OC is the time for this change. So that we can take as T. From this we can take BD is equal to, again BD is equal to, we multiply this way. That is BD is equal to AT. That we can take as relation 2. Now look at the relation 1 and 2. What is the relation 1? Relation 1 is BD is equal to B minus U. And relation 2, BD is equal to AT. So from these two, left side of these two equations equal. So BD is equal to B minus U, BD is equal to AT. So B minus U is equal to AT, or B is equal to U. This minus U when shifted to this side, it will come plus U and this AT. This is the first relation. V is equal to U plus AT. V is equal to U plus AT. This is the first relation we got from this graph. That is V is equal to U plus AT. Now we are going to find the second relation, that is S equal to U T plus half AT square. That is, S means position and T time relation. Position time relation. See, we know from the graph, displacement is equal to, here displacement equal to area. So that is equal to, that we can take as area of the rectangle OADC plus area of triangle ADB. Area of triangle ADB. That is equal to, area of the rectangle is equal to length into breadth, that is equal to OA into OC plus area of triangle is half base into height, that is AD, that is half into AD into this BD. That means area of the rectangle OA into OC plus area of the triangle half base into height. That is OA is U and OC is T time. That is UT plus half into AD, A to D, that is equal to OC time T. So half into T into BD. But we know BD before we got as AT. So UT plus half into T into AT, that is equal to, this is the displacement, S equal to UT plus half T into AT, that is AT square. This is the second relation, that is S equal to UT plus half AT square. Now we got two relations on V is equal to U plus AT, and second one is S equal to UT plus half AT square. Now we want to get the third relation, that is position with velocity. Position velocity relation. Position velocity relation. You know this figure, O, that means the displacement equal to this area of the trapezium. OABC. That means the displacement is equal to area of the trapezium OABC. We know area of the trapezium is equal to half of the parallel sides, sum of the half of the parallel side. Here OA and BC are the parallel side into perpendicular distance OC. So this we can write as OA plus BC by 2, half into perpendicular height, that is OC. Once again, that is OA. We know how much OA is the initial velocity U plus what is B? BC? BC is the final velocity V by 2 into OC is the time relation T. This is the displacement. So S is equal to U plus V by 2 into T. Now once again, that is S is equal to this U plus V by 2 into, from the first relation, that is from the first relation we know V is equal to U plus AT, or from this AT is equal to V minus U, or T is equal to V minus U by T. U minus V minus U by A. That is the first relation V is equal to U plus AT. From this AT is equal to V minus U, or T is equal to V minus U by A. Putting this value in this equation instead of T, then what we get into V minus U by A. Now S equal to U plus V by 2 into V minus U by A. Now see this relation, these two are these two are in the denominator. That you bring to this side. This denominator quantity come to this side, it will become in the numerator. So that 2A and here on S is equal to 2AS equal to U plus V into U minus V. We know this now in the form of A plus V into A minus V. We know A plus V into A minus V is equal to A square minus B square. Similarly, U plus V into V minus U. This we can write as V plus U. So this becomes as V square minus U square. This is the required third equation. This is the required third equation, that is position velocity relation. Now three relations we got, which are they? One is V is equal to U plus AT. Second one is S equal to UT plus half AT square. And third one is that is 2A is equal to V square minus U square. With this, we want to solve some problems that is given in our text. See, the first one is a train starting from Rust attains a velocity of 72 km per hour in 5 minutes. Assuming that the acceleration is uniform, find the acceleration, the distance travelled by the train for attaining this velocity. A train starting from Rust attains a velocity of 72 km per hour. See, it is starting from Rust, so its initial velocity is 0. And it attains a velocity of 72 km. So its final velocity V is equal to 72 km per hour. And the time taken for this one is T is equal to 5 minutes. Now we want to find out two things on its uniform acceleration, how much, then the distance travelled by it, that is yes, these two things we want to find out. See, U initial velocity we know 0 meter per second, and its final velocity V is equal to 72 km per hour. This kilometer per hour we can convert as meter per second. That is 72 into, by multiplying with 5 by 18. 5 by 18, because this kilometer we multiply with 1000 and this hour is dividing with 60 into 60. On simplifying we get it as 5 by 80. So to convert to kilometer per hour into meter per second, we multiplied it with 5 by 80. We know in 72, 18 is 4 times. So V is equal to how much? 4 into 5, 20 meter per second. V is equal to 20 meter per second. Now what we want to find out? At first we want to find out acceleration. For that we can take V is equal to U plus AT. Here V, final velocity 20 meter per second. Here unit is, we can put after solving the problems. So V 20 meter per second and U initial velocity is started from rest 0 plus A, which we don't know, A into the T time taken 15 minutes. That is 5 into 60 second. Minute we want to convert it into second. T is 5 minutes. That is equal to 5 into 60. Here we can write as 5 into 60 in second. Now, if we add this 0 to this, there is no change. So, to get A, that is equal to this 0 we cancel. Then what we get? A into 5 into 60 is equal to 20. So A is equal to 20 divided by 5 into 60. That is 1 0 we can cancel from this, and 2 and 6 we can cancel. Then what we get here? 1 times 2, here 3 times 2. 3 into 5, 15. 1 by 15. Acceleration unit is meter per second square. So first answer we got A is equal to how much? 15. That is 1 by 15. 1 by 15 meter per second square. Meter per second square. That is the acceleration of the train. Now second things we want to find, that is the displacement or distance traveled by the train. For that we can use any of the two equations, S equal to ut plus half at square or V square minus U square is equal to S. Any equation by solving you get the same answer. Now suppose we are going to use the first equation is equal to U into T plus half A T square. Suppose S equal to, here U initial velocity 0 into time, if you put that also is 0. So I am not going to put the value. Plus half A, how much? 1 by 15 into T. T is 5 into 16. This much time taken. So 5 into 60, 5 into 60 the whole square. That is equal to S equal to this terms we can simply avoid, because T we can put it as this value, but it is multiplied with 0, so it has no value. So this is 1 by 2 into 1 by 15 into this square means 5 into 60. Into again will come because it is 2 times 5 into 60. Why we write in this way? Because we can cancel some of the terms from here. See, next step I am going to write here, that is S equal to this 2 and this 60 cancelling. Then what we get? 30 will get. Okay. Now this 15 and 30 we can cancel again. Then in 30 how many times 15? 2 times. So here we will get it 2. Now see. What are we getting? 5 into 2, 10 into 5 into 60. See, 5 times 6 is 30. Then this 0 and again this 0. That is 3000 meter. That is a train travel 3000 meter. We know 1000 meter is 1 kilometer. So 3000 meter is 3 kilometer. This is the distance traveled by the train within that time. So we got acceleration that is 1 by 15 meter per second square, and now distance 3000 meter or 3 kilometer is the distance traveled by that train. Now another one problem given to you is that a car accelerates uniformly from 18 kilometer to 36 kilometer in 5 seconds. You want to find acceleration and distance covered. At first speed u is equal to 18 kilometer per hour. Then its speed become final velocity, that means 36 kilometer per hour. And the time taken for this t is equal to within 5 seconds this is happened. Once again the question, a car accelerates uniformly from 18 kilometer per hour to 36 kilometer per hour in 5 seconds. What are the things we want to find? We should find first of all acceleration, then distance travel. These two things we want to get. See, this kilometer per hour to change at first velocity is initial velocity 18 into. How to convert a kilometer per hour? By multiplying with 5 by 18. See, this 18 and 18 cancel, what remains there? That is equal to 5. So, u is equal to, we got as 5 meter per second. Then, similarly 36 equal to convert to 36 kilometer per hour, 36 into 5 by 18. So, here 2 into 5, v is equal to 10 meter per second. And t is 5 seconds itself. T is equal to 5 seconds itself. Now we can find out two terms. At first, a from the relation v is equal to u plus a t. V is we got what is from this relation a is equal to v minus u by t. That is equal to v10 minus u5 by t5. From 10, when we subtract 5, we get 5. 5 by 5, that is equal to 1 meter per second square. This is the acceleration. And we want to find out that distance traveled. That is s equal to ut plus half a t square. That is equal to u5 into t. That is equal to how much? T is 5 seconds plus half into a 1 meter per second square into t, 5 square. That is equal to 5 into 5, 25 plus 1 into 1, 1, 5 square 25 by 2. 25 by 2 means 12.5. So 25 plus 12.5 is equal to, that is 30, that is 25 plus 12.5, that is equal to 37.5 meter. That is the displacement. That is displacement is how much? 37.5 meter is the displacement of the car. So we got the two answer. Acceleration is how much? 1 meter per second square, and the distance traveled by the car is equal to 37.5 meter. This is the distance traveled by the car within that 5 seconds. Now another question given to you is that third question given to you. The brake applied to a car produces an acceleration of 6 meter per second square in the opposite direction of motion. If the car takes 2 seconds to stop after applying the brakes, calculate the distance traveled during this time. the brake applied to a car produces an acceleration of, that means A is equal to 6 meter per second square. See, to the opposite direction of motion. That means car is moving forward, acceleration is in the backward, so A is equal to minus 6 meter per second square. In the opposite direction, if the car takes 2 seconds to stop, that means car taken how long? That is 2 seconds. Now, we want to find out distance traveled by the car, that is S equal to how much? We know that means car is stopped. So V is equal to 0. Final velocity becomes 0. Now its initial velocity, we want to find out the distance traveled by the car. For that we want to get what is at its initial velocity, because we know S equal to ut plus half it square. Their initial velocity is required. So we know V is equal to u plus at, the equation. In this equation, final velocity is 0 is equal to u. U is not given, plus a, that is minus 6 into t, that is 2 second. Unit we can put later on. So u is equal to, from this 6 into 2, 12, that is minus, when you bring to the other side it becomes positive. So 12 meter per second. U is equal to 12 meter per second. So we can write the equation S equal to ut plus half a t square for finding distance travelled by the car when brake is applied. So S equal to ut plus half at square, that is S again equal to u, that is 12 into t, time taken 2 seconds, plus half into a is minus 6 into t is how much? 2 and it's square. So 12 into 2 is equal to 24, plus into this minus become minus, plus into this minus become minus, 6 by 2, 6 by 2 is 3, 2 square is 4. See, this 6 when we divide with 2 we get 3, this 2 square is 4, then 3 into 4 is 12. That is equal to 24 minus 12, that is 12 meter. So after applying brake, the car travels 12 meter to stop. This is why we used to say that always moving vehicles want to keep some distance, because if that distance is not there, there may be some accident, because the car applied brake, even though applying brake, that car comes to rest after traveling 12 meter. If there is any vehicles within this distance, there is a chance of collision. That is why always keep that, we used to say, that is why we used to say when driving, the certain distance must keep between the vehicles in order to avoid accidents, because braking distance there is always some braking distance for a moving vehicle. Now we can do some more questions which is given in our text. Okay. Now we can practice one more questions which is given in our text. A bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. Find the speed acquired, the distance travelled. Once again, a bus starting from rest. The bus is starting from rest, so its initial velocity is 0 meter per second. moves with the uniform acceleration. That is, acceleration is given 0.1 meter per second square. Moves with the uniform acceleration of 0.1 meter per second square for 2 minutes. For 2 minutes, that is t is equal to 2 minutes. That we want to convert it into second, 2 into 60 seconds. Then the things you want to find: speed acquired and the distance traveled. That means what is the speed now itself and the distance, how much it cover. It cover how much distance. That two things, distance traveled. See here, we know it starts from rest 0, acceleration, time given. So we can find out its final speed acquired. V is equal to u plus a t. V is equal to u. Its initial speed is how much? Initially it starts from rest. So 0 plus a. It is accelerating how much? 0.1 into, unit is not writing here, you can write it later, into t, time taken is 2 minutes, that is 2 into 60 seconds. That also unit we can write later on. That is v is equal to 0 plus, that is 0 is adding to any quantity, that is there is no change, that does not change. So 2 into 60, 120. When 120 is multiplied with 1, that is also 120, but there is no decimal, so it becomes 12 meter per second. Since unit of velocity is meter per second, v is equal to 12 meter per second. Okay. Now one quantity we got, that is 12 meter per second is the speed acquired. Now we want to find out distance it traveled. We can use v square is equal to u square plus 2as, or s is equal to ut plus half a t square. Let us use this relation, that is 2as equal to v square minus u square. See, 2 into a, that is here given 0.1 into s is equal to v square. V is 12, so 12 square minus 0 square. That is this s we can keep here. That's 12 square is 144. 12 square is 144. 0 square is 0. So from 144 you want to take 0. That means nothing we want to take. Now to get s, 2 into 0.1 means 0.2. That is equal to 144 divided by 0.2. That is equal to remove this point or decimal, we multiply upside with 10. Now it becomes 1440 by 2. Now this 1440, when we divide it with the 2, in 1 we cannot take it 2. 14, how many times? 7 times. In 4, 2 times 0, 0 times. That is equal to 720 meter. So its distance traveled is 720 meter. So we got which are the terms on its speed. V is equal to how much? 12 meter per second. And also now we got how much distance it traveled. It traveled a distance of 720 meter. Okay. Now we discussed the terms, some equations from graph. Which are the equations we got? On v is equal to u plus at. Second equation is s equal to ut plus half at square, and third one is v square minus u square is equal to 2as. And also we did a number of numerical problems related to this, and with this we can wind up the class today.